Hello there everyone, this is Abhinandan and today I'll show you how to trim a binary search tree. So what is a binary search tree? A binary search tree is a binary tree which means that it has two children but it has a special property. The left child would always have a smaller value than its parent, whereas the right child would always have a larger value than its parent. For example, see this. 27's left child is 14, which is less than 27, and 27's right child is 35. However, when it comes to 14, 14's left child is 10, and his right child is 19, which is greater than 14, whereas 10 is less than 14. Likewise, at 35, his left child is 31, and the right child is 42. So, what do you mean by trim? It basically means to get a binary tree containing values within a smaller range. For example, if I have a binary tree consisting of 100 nodes, like 100 numbers from 1 to 100, but then I only want to see the numbers from 1 to 5, then I will need to use this trim. So the logic behind my method of solving, one is it follows a recursion algorithm, and the worst case was the time complexity is big O n. So for example, consider this tree having 1, 0 and 2. Now if I set my left range as 1 and I set my right range as 2, my output should be of the following. That is, it should remove that 0 and get me a tree as such, a tree which follows the properties of a binary search tree. So my values should be 1 and 2. So this is the question as shown in lead code, problem 669, trimming a binary search tree. So let's begin. Since you are going to use a recursive approach, you always need to find the conditions where the recursion is stopped. That is, in this case, since you are using a 3 node, you will have to return something. So since you are starting to traverse from the root and down, one of our cases would be we are reaching the leaf node and there is no more nodes to search. So that's one of our conditions when the 3 node is null. So if root equals null, we just return the root as such. Now next condition is when our the value is not within those set of boundaries. That is when, for example, if you are given here 1, 2 as boundaries, our value should only consist of values within 1, 2 within the 3. Root value is either less than the lower value, or it's greater than the higher value. So let's check with the higher value. If root.var greater than r, we continue with the recursion but in a different way. Trim BST, trim BST with root.left, because the left child of the parent will always consist of a lower value. So we always go to the left, since our current value is right now higher than the boundary value. And likewise, when our root.value is less than the lower value, we return trim BST with root.right, left, r. A left, r never changes because those are our boundaries which you have set, in case you haven't understood yet. Now we have gone to all the possible cases. Now we have to manipulate the object we got. So after this much code, the final object, that is the root's value, is assured to be not null and within those boundaries. Now we only got the parent. Now we have to decide its left children and the right children. So we type root.left is equal to trim BST of root.left, L, R. And likewise root.right, we type trim BST root.right, left comma right. I'm sorry if I say left and right as L and R. I hope you understand. Now for final, we just return root because it's recursion. We have to always. Sorry again. I accidentally press Ctrl S. So we return root. As you know, it requires a 3-node object, and so we return root, which is a 3-node object. Now, fingers crossed. Let's run the code. As you can see, an output and our expected output is correct. So let's submit and try. Yes, so our answer is correct as uploaded by lead code. So I'm going to explain with this example 3, 0, 4, 2 and 1, with the left boundary being 1 and right boundary being 3. This is the 3 which I've entered right now. Now it starts from 3, right? The root is not null, so it goes to and checks with the value. Root the value is greater than R? No. Is it less than L? No. So we go to set its root dot left. So this is a root as such. Now we are going to modify its left and right children. In root dot left we call another trim BST. And here we can see that its root value is actually less than a lower value. So from here we directly call the root dot right, which is 2. 2 is the correct value, so instead of 0 now it becomes 2 here. And likewise, since 2 is set, now we go for 2's left children and right children. Right doesn't have a child, so this returns null. Left has 1, which actually doesn't change because 1 is within the required boundary. However, on the right side we can see it's 4. 4 is above the required value. So when you return the trim BST of that, we can see that 4 has no children. So the left child of 4 and right child of 4 would be null and null. And since we already used the trim to bypass 4, finally the object return will also be null. So 3 would be having null as the right child, whereas it will be having 2 and 1 as the left. So the thing in lead code is that you only need to type the method. If you know the algorithm, you will be able to solve it. So what about the implementation part? We follow an object-oriented programming approach. So everything is defined as an object. Now we know that this trim is a functionality of a 3-node. So if I'm going to create anything else, for example, I'm going to create a class 3, having an object root which is of the class, which is of the type 3-node. So if I want to call a method such as trims, I would not need another function in 3 to trim it. I could just call a trim function, which in turn just calls the trim BST function, which is within the root. So the functionality of the trim is going to the 3-node and not to the 3. So before I wrap up things, I would like to say that the trim method does not modify the object which calls it. However, it just rather returns another object. It is kind of similar to how string works, how replace function strings work. For example, if I have a string s called QWERTY, and I simply call s.replace qw with rr, and if I try running it, it's only going to give me qwerty as such, because s is not getting modified. Now instead of that, if I change it to s is equal to s.replace, and if I try running this, you can see that it has changed to rr. Likewise, if you simply create an object of 3 and use, for example, if you create object 3 node of a, and if you simply type 3 node a, the trim, this is wrong. And you'll have to say a is equal to a dot trim 2 comma 5 if you want my code to work as such, because it doesn't modify the object, it rather returns a new object. So thank you everyone so much. You're always welcome. Bye bye.